Stretching and shrinking, problem 9, to the end. The following table gives key coordinates for drawing a backpack for the Wumps. Remember the Wumps? I remember the Wumps. Backpack 1 is plotted on the grid. Sweet. Find the coordinates for the drawing of the other backpacks. Well, nicely, it gives us the coordinates for backpack 1. We need to make the other ones, right? So we just apply the rule. What's it mean when, well, let's just do backpack 2 first. What's it mean when a number is next to a letter? Well, it means multiply. So we're saying 2 times the x and 2 times the y. So 0 times 2 is 0. 2 times 2 is 4. 2 times 8 is 16. 2 times 2 is 4. 2 times 6 is 12. I'm just going to go through now. I hope you see the pattern. For backpack 3, we will add them up again. So this time we're adding 8 to the x and subtracting 2. 0 plus 8 is 8. Y minus 2, or 2 minus 2 is 0. 16, comma, 0. 14, comma, 3. 10, comma, not 7. 5 minus 2 again is 3. And then 0 plus 8 is 8. 2 minus 2 again is 0. Backpack 4. We have x stays the same. Well, that makes life easy. I'm just going to copy those down, right? And then we're multiplying y by 2. So we have 4, 4, 10, 10, and 4. So now we are being asked to make these backpacks. All right, so I'm going to try to go as fast as possible. Backpack 1 has already been made for us. We have backpack 2, so 0 over 4 up. 1, 2, 3, 4. 16, comma 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, comma 4. Remember, this is 0, so 0, 1, 2, 3, 4, right? So then the next one is going to be 12, comma 10. So 16, counting backwards from 16, 15, 14, 13, 12, 10. That's 4, 5, 6, 7, 8, 9, 10. 4, comma 10. 1, 2, 3, 4. And again, remember this line is the 0 line. And so then we have our backpack here. For our next backpack, now I can't see my numbers. Brilliant. Okay, we have 0, comma 8. And again, this is our 0, so 8 over. So there's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 0 up. Okay, well that's right there, right? Sorry, it's a little high. Unfortunately, I need to put it there so I can see and plot at the same time. So then we have 16, comma 0, which is going to be, there's 8, 9, 10, 11, 12, 13, 14, 15, 16. Then we have 14, comma 3, so 1, 2, 3 up. Here's 16, 15, 14. And so I can connect those. And then we have 10, comma 3. So there we have it. And I noticed that all 3 of these are similar. I know they're similar because these angles are all the same. And I noticed that this one and this one are congruent because they are identical. They've just been moved along the grid. Well, to cut to the chase, I'm going to make backpack 4 right here so that we can see what happens here. Come on, give me the eraser. Come on, erase. There we go. All right. So now we have 0, comma 4, so that's 0 over 4 up, 1, 2, 3, 4. And now we have 8, comma 4. 1, 2, 3, 4, 5, 6, 7, 8, and we're already 4 up, that's great. So now 6, comma 10. So 6 is going to be here, 10 is going to be way up here. And I can tell already that this is backpack, this angle here is much steeper than that angle here. So here's the rest of my backpack. I've noticed that the backpack has been smushed or elongated on, in the vertical direction, and therefore it is not similar. It just doesn't have the same general shape and it doesn't have the same angles. So which backpacks are similar? 1, 2, and 3, but not 4. And that is, we've explained the same angles and the same general shape. Okay, use these two similar parallelograms to answer the questions. So we know they're similar. So the first thing I'm going to do is I'm going to count. Well, we've gone 1, 2, 3, 4, 5, 6. And it used to be 2, now it's 6. Well, what did I do to 2 to get 6? Well, I multiplied it by 3. So my rule is going to be, I have my x, come on, comma y. And what did I do to x, comma y? Well, I multiplied it by 3. And I learn, and I know, that I have to be multiplying by the same number to the x and y to create a similar shape. Because in backpack 4, I multiplied 1 by 1, x by 1, because it didn't change. I multiplied y by 2, and I got a tall, skinny one. Write a rule that finds the coordinates of any point in parallelogram B to the corresponding. Okay, well, now we're working backwards. So if I multiplied by 3 to work backwards, I'm going to multiply by the reciprocal, and we talked about that. The reciprocal of 3 is 1/3. There we go. What is the scale factor that relates? Well, scale factor obviously is 3. And finally, for the last page of stretching and shrinking summer fun, consider the two parallelograms below. Okay. Does the diagram provide enough information to determine whether the two parallelograms are similar? If not, what information do you need? Well, obviously it looks like you have similar angles, but that's not enough. You have to have a similar side length. So the question is, what did I multiply 4 by to get 6? Well, if I do that image over original idea, and I'm going from the small to the big, that's 6 over 4. And 6 over 4 is equal to 3 over 2. So all of them have to be equal to 3 over 2, right? So obviously this matches here. Excuse me. So let's see if these two match. So 12 over 8 is equal to, well, 4 goes into both of them, right? So that's 2. Well, that works out just fine. And then let's try these two. So we have 9 over 6. 9 over 6 is, because 3 goes into both of them. So yes, we have enough information. Not only that, they are similar. That we have enough information because we can find scale factor, and one scale factor relates corresponding sides of similar figures. Suppose the parallelograms are similar. Write two ratios that compare the corresponding side lengths. Okay, well, we did one of them. So this is the scale factor from big to small. So what's the scale factor the opposite way? Well, the scale factor from small to big is going to be the reciprocal, or 2/3. Find the ratio of two adjacent side lengths. All right, so adjacent means next to each other, right? So I'm going to do this in a different color. So how about these two? These two are adjacent. So we have 6 and 8. So there's a ratio, and the corresponding ratio would be 9 over 12. And are these equal? Well, yes, they're equal, because they're both equal to 3/4. What is the scale factor that relates the corresponding sides? We've already answered that. There are two of them, from small to big, and from, oh, sorry. So this is from big to small, and this is from small to big. All right, and that is stretching and shrinking.